So in this demonstration, we're trying to show how the program called Gerwalk law adjust worked. Essentially, we're going to show further effect of the torque limit. Okay, so the program start out with setting a slope for everybody. All the servos 32 is standard. Margin for all everybody at 2, and this is the punch for everybody at 32. So if you remember previously from the other video, so this one here is when you choose dynamic mixel, the tskx series, you choose the slope, and instead of normally servo ID 1, 2, 3, 4, 5, if you scroll all the way down, you can choose all, and that means for everybody. And then this one here, because the punch is not among the normal list of parameters that the robotist people that you control, you have to kind of do a custom command. This is under custom here, and then instead of the ID, you put 254. That's equivalent of all. And the punch parameter is address 48, and it's a size of a word. Okay. So the program started, I call init. Let's go down and see what call init does. It target position 512. That's trying to set up the initial pose of the Gerwalk essentially. A parameter called allowed error called 2. So essentially target position 512 plus or minus 2. So it will let you do 5. It will try to control it between 510 and essentially 514 essentially. Set torque 4 and 5 I set to 1 because we want to control the servo 4 and 5 special here. Let me turn it off to save the battery here. The torque step, each time is changed by 1. So first, in the init, it go high velocity, high torque, and everybody go to 512. Okay, and it got 2 seconds to do that. So after it's done, just to be sure, slow down a little bit and set go torque to stiff again, just to be in case to stiffen the position, to give it some time to stabilize here. It really doesn't do. That's it's a goal to do it here. And then this is the key. I'm resetting the torque limit for 4 and 5 to set torque 4 and set torque 5, which is 1. Okay, that means what? I'm going to make the equivalent of the knee for a Gerwalk, make it soft so I can change it. Okay, this is stiff. This is still stiff. Everybody else still stiff except for the equivalent of the knee for the Gerwalk will stiff. That means it will let me do that. So it read whatever present position is. It should be around like 512. It saves as target number 4, target number 5. It figures the high value of the target and the low value of the target for servo 4, which is this one, the right servo. And then 5, the high end of 5 for servo 5, and the low end of servo 5. And then it's done with the function init. So done with that, we then go to an endless loop, a big endless loop. And in the endless loop, it have 2 if statement. Essentially, this one in English, it say that, oh, if you're bigger than high 4, that means the high end of a target position. Or if you're lower than the target position, low 4, that means basically when you're out of the target position, which is roughly 512, so that means you're up here, or you could be off that way. You need to bring back. Okay, so what it does, it does that. What it does is, remember, set torque originally down here was equal to 1. with the init function. So it will start out at 1, but this one here, as long because this is an endless loop, and the if statement say as long as you are out of the target zone, you need to increase your set torque 4 by 1. So that means every time it's out, it keep on increasing this because the endless loop could be looping several times. So that means the goal torque start out at 1, and then it increase by 1 each time we go through the endless loop. So basically, it gets stiffened up. Stiffen up means more current into 4 and 5. So we will see that the leg, after I push away from the target position, it will go back to it slowly by 1. Slowly in it. But once it's going, because the torque is stiffen now, it will not really change it again. Similarly, I can do the thing for 5. So every time it goes through the endless loop, also it's set the ID equal to 4. I call print data. And what does print data do? We just print out that ID. That means print out ID number 4. It print out the current torque limit. You're going to see it start out low and go high, and then the present position, and then print the so-called present load. So it will do that for ID equal 4, and then print it for ID equal 5. So it's going to stream out a bunch of data. Now you can see the way it's set up is this if statement is once you set up a high torque, it doesn't set it down again. Okay, and then I'm using the virtual controller, virtual RC 100 remote controller to use it too. So anytime I push on it, and I push anything but button 1, it will not do anything. It will keep this the leg stiff. But I push 1, it call init again. That means what? It soften and reset everything. All right, so that kind of the software not working. Let me keep it endless loop here because that's important. So let me power on, COM3, and download the code. You output program. And I'm going to pop out the virtual RC100. Oh, hang on. Let me arrange it so that you can see the number running down here. With it in it. Okay. So now we're ready to go. I'm going to put start button. So you see it go into that position. Okay. So you see 4, 5, 4, 5, and the torque limit, the goal torque right now, as you see, is 1 bay. So it's bouncing around 5.1, 5.11. So the torque limit is 1. So that means it's up. I can change it. So I'm going to push on 4. You see, it will yield, and then coming back. But now see the torque limit is 193. So it's high. I cannot change it anymore. Yeah, every time I push it, it will force it to go higher and higher and higher. So the torque limit go higher. But you notice 5 is still at 1. Okay, so I can play with that. It's coming back up, but now I cannot change it. Okay, it won't go anymore. Now I can push any button, it won't do anything on the virtual remote controller. If I push 1, see, it took some time, but it reset everything back to 1. So now I can play with it again. Okay, until I push 1 again. It went into call init. You see, this stopped displaying for a while. All right.